Hello, and welcome back to my YouTube channel. My name is Professor Govalla, and today I'm going to be talking to you about the series combination of inductors. And essentially, what we want to do here is analyze a situation where we're given inductors in series, and we want to devise a way of combining them to become an equivalent inductance. All right, so what we're going to do here is we're going to say that this is case 1 and this is case 2, where this is the equivalent circuit. All right, and what we're going to do is we're going to write some equations for case 1. Let me zoom out here. I'm going to say that case 1, we know that the voltage across the inductor, this is plus minus V1, plus minus V2, and plus minus V3. And mesh analysis tells us that the voltage going into my circuit, Vs, must equate to all the voltage drops in that loop or in that circuit, right? So V1 plus V2 plus V3, and this is equals to the inductance, or the inductance, L1 d Is over dt plus L2, let me zoom in, L2 d Is over dt plus L3, the current across, the change in current, Is, over the change in time, over time. And if you don't remember, or if you don't understand where these equations are coming from, I do have an inductance video that goes in detail about how this equation is it comes about. So please feel free to check that out. So let's go ahead and call this equation 1. And I'm going to say that equation 2 is Vs. I'm going to go ahead and pull out a dis over dt, and I'm left with L1 plus L2 plus L3. All right, I'm going to call this equation 2. Okay, and now for case 2, we note that we want to find the voltage drop across this equivalent inductance. So plus minus, let me call this Vs because it's in parallel with my source voltage. So then Vs is equals to L equivalent times the change in my current Is over dt. And let me call this equation 3. So what I can say now is that if I'm given case 1 and I want to map it to case 2, this means that equation 2 has to equal equation 3. Or we can say then that dis over dt times L1 plus L2 plus L3 must equate to L equivalent dis over dt. And obviously the dis over dt cancel out, and I'm left with this equation. L equivalent is equals to L1 plus L2 plus L3. So this leads us to writing out what I consider to be the general equation. So we can say here then that the general equation for an inductor in series is L equivalent is equals to L1 plus L2 plus dot 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 plus Ln, which is simply the sum of I is equals to 1 to n Li. All right. And if you found this video helpful, please give it a thumbs up. If you found it a bit confusing, or if you didn't understand the full video, please leave a comment down in the comment section below, and I'll be sure to get back to you. Please remember to share the video and subscribe to my YouTube channel. Thank you.